So hello everybody, this is my first time competing on the Div.4 round. I will be recording this round here. I'm recording it for future references, for just to see how it went, and somebody may need like some solutions and some help after the round has ended. So this is not a stream, of course, and because it's Div.4 round, I won't speed run it. I'll just try to solve all of them, but I will do it slowly. I just don't care because it's I'm out of competition, so it won't hurt my rating. Just we're gonna slowly go through them and explain. Given a Latin lowercase, check it if it appears in the string CodeForces, so I can just copy the string CodeForces, of course, and there I have like string cf is this, then some character which I'm going to input, then I will, for each character in cf, if element is equal to that character, I'm going to see out yes, I'm going to return, otherwise I'm going to see out no. I said I won't speed run it, but this is pretty straightforward, so I'm just going to submit. It's laggy because 30,000 people are following directions. Okay, we got accepted. On A, let's go B, if it would load B. Okay, following directions, so there's some L and R, and then you start at probably 0.00, and you want to know where you want to know there is candidate 1, 1. It to determine if ever passes the candy. So I'm just going to have again test cases, some string s, which are going to be the directions, and I start at 0, 0, and then for each of my string size I will have like, yeah, let's just do this. So if s is if s at I equals up, we're gonna so x is what, yeah, it doesn't matter, so we're gonna just I'm just going to go y++, else if s of I is down, y minus, else if s of I is right, x++, else x minus, if x equal and y equal 1, then we see out yes, and we return. We don't care to know that, we don't care where, just want to know if it passes the candy or not. This is done, so let's just submit. C has a binary string, he will perform the following operation. Let me just in Q, okay. He performed the following operation: several, add 0 to the end of the string, add 1 to the other end of the string. For example, starting your given final string, what is the length of the shortest possible string he could have started with? So this is like, we just go with like 2 pointers, and we see when we reach like 1 and 1 or 0 and 0, we end up there. So it's just a simple, it's not really 2-pointer technique, it's just till n half, and then I will go like if s of I is equal to s of I n minus 1 minus I, then I need to see out n divided by 2 minus I or something. Why is 5 here? It's n minus I times 2, right? If he can possibly of length 0, so he can just do this, right? Yeah. Possibly of length 0, I thought it's going to be length 1. Actually, I'm not sure about that one, but whatever. I'm just gonna go to the next one. Let's denote f of x to be a function of string. Let me see if it's got. Okay, it's still in Q. String is the number of distinct characters a string contains. Okay, given a string split in two non-empty strings A and B such that this is the maximum. Okay, so this is just you could solve this in multiple ways. But I will go and keep like a set of characters from one of the sides, and then from like the back side, and then I will say this is like suffix array, and then I will start at the back of the array, and then I'll say back dot insert s at I, the suffix of I is back dot, and then I'm going to say front, and then I will go here, can A and B be empty? A be empty string? Doesn't matter. S answer is the maximum of answer, and from dot size plus suffix of I plus 1. Passes, just submit it. Still in queue? Wow. Okay. Given an array of n integers and elements, find the maximum possible sum of the array can have after performing the following operation any number of times. To choose, then flip both of their signs. In other words, choose. Okay. So we get the sum, and then for each of these, I'm going to flip them both. I'm going to say answer is the sum, and then I will say, okay, L current is the sum, and then current minus 2 times A, current minus 2 times A plus 1, and then answer is max of answer and current, same answer. Twice negating something is equal as like subtracting twice. Okay, let's go to the F, problem F. Given an array, you have to handle Q queries, L and R indices, update the value AI to the sum of the digit. For each index, update the value of AI to the sum of the digits of AI. The sum of the digits of AI. I'll put AX. It will become after, sometimes it will become after like some iterations, the value will become like one number, and what we want to do is we want to have like we can do a sec tree here. Are there tests? Yes. So why is not sec tree? Just copy some sec. I mean, I don't need to do sec. Like I could just do I don't need to build a sec tree. I could just do this and then ask from L and R what return an integer. Wait, I had some. Why don't I have the snippet here though? Wait, I have a snippet. Yeah. Value is default. We are going to add onto the value. s is going to be equal to at most n. For each query, we are going to ask for the type of the query. From L to R. Oh, do I need lazy? Wait, L to R. Yeah, I do need lazy, right? I'll just do a destructor here. If it's type 1, we're gonna add from L to R, so from U to V, we are going to add 1. And then if it's type this, I'm going to query x plus 1. If x is smaller than, if a of x is smaller than 10, we are going to break. If not, we are going to sum up the digits. That's it, and we are going to do a at x is equal to the sum, right? Just switch all to higher a, and then see out a at x, and then 3 dot at x and x plus 1 minus v see out and 1. Okay, so that should theoretically work. It's 2. Performed yielding this thing here. Oh, it's not X, it's V. Wait. Minus negative. What is this querying? Oh, it's querying the plus, of course. Add to that value. Value is the plus of that value. Value is 0. Am I not querying something? Okay. Definitely not querying. Okay. Oh, 0. Okay, that seems. Oops. Okay, that seems that it passes. Let's just submit. Okay, this was slow. Oh, we have wrong answer, negatives and positives. Oh, any number of times, not just one. Oh, totally disregarded that. Totally disregarded that. Any number of times means that we flip. We can always flip. It's always a sum that it's everything except one element. It's like yeah, it's okay. I'm sorry, it's not like this. The sum is like everything except the minimal element, which is minimum and the absolute value of this, and then the sum is the absolute value of this minus minimum. Okay, whatever, just put it. Div.4 passed. Still in queue. Okay, so we have like problem E and problem G. Let's try to solve problem G. Consider the locations. A teleporter located at point you can move one. Use a teleporter at point if it exists. Cost AI coins. As a result, you can choose whether to teleport to. Okay, you can't use it again. You have and you start at point 0. What is the most number of teleports you can do? There's some kind of DP. So like you move this. Use AI coins, and you start with how many coins? You start with like 10 to the 9 coins. Okay, let's solve. I don't know. I'm not sure about problem G. Just so here, so we solve E. Why is this not correct? Why can't I just choose the minimum of all of this? Yeah, it's like 2 times the minimum, right? But sometimes it can be more. If what? If the if it is divisible, then it's like 0, right? I'll just submit it like this. I think that's correct. It's laggy though, and F is still in. Okay, and now G is okay. Let's try to solve the hard version as well, right? It will cost AI coins to teleport. I want to teleport to, like, I will always teleport at the nearest location with the last with very little coins, right? So it's like some kind of convex, but it's not convex hole. It's I add one and then teleport here, or I add one and teleport here, or I add one and teleport here, and then that's from the other side as well, and then just try to do that, but then like a priority queue. So like first you teleport. Do you always teleport from the no, it's so laggy that just I don't know. They're both in queue. Do you always teleport at the same point? Yes, you do. Right. Like the minimum cost for teleportation is the. Okay, let's say a vector. Okay, and then I will say okay, I will pick first the ith value. So I will say I plus is the cost. If cost is bigger than C, then I can just continue. In other case, I have some target. Max target is like C minus cost. And then I will binary search where that target can be found. So the answer is going to be I think it's just like this somehow. I don't even have to check here. Lots of things. Yeah, I need to sort them. Okay, minimums are going to need to be sorted. What the fuck? Okay, minimums need to be sorted first. 2 here. So let's look at the prefix array here. Oh, here. This should be equal to that. I'm not sure if that should be equal to that as well. Seems correct. Zero. There are 3 coins, which I can teleport once here. So the cost yeah, so in case that the current answer this has to be 1. So that seems to work. Just submit the code. See. Yeah, that should pass. Wrong answer on test 5. How is... maybe it was an overflow or something. Yeah, overflow. Nice tests. Okay, so yeah, it was overflow. Okay, so we solved it all. It's slowly testing. It's slow. I don't know. I don't know why I didn't come up with a solution on G faster. But yeah, that's it. Like I binary search here. I take out some element and then I binary search where the optimal solution, how much I can get from the remaining, and that works. That's just wonderful. Although penalty, yeah, there are penalty. I don't care. Like just it's a practice round, and yeah. So that's it. Let's just recap on F. So on F, what I do is I see that when like I want to add in the segment tree, in the lazy segment tree, I add on this interval like +1, and then when I query, I know how many times this has been increased. This has been like recursively, I mean not increase but decrease. Like how many times this has been this first operation has been done on one element, and then I take this many times. I go through the element, but when it like decreases to 10, I know that under 10, I know that the digit will be the element itself. So if it's like, if the element is 6, it will be 6 again and 6 again. So I don't have to calculate that many times. Actually, I can just break, and that makes it the amortized complexity. Like that makes it why you can have like at most probably 10 times or like 20 or like some log n times the digit. Maybe it will change. I don't know, like I'm not sure, like I need to prove that, but this probably like at most log n times will be answered. And then I reset at that vertex at the tree -v, so minus these v operations that I have already done, and I print a of x. So I mean, it's a cool solution. It's a cool problem, a very good problem actually. G1, G2 I didn't quite like, but either way, G2 is like pretty nice. It's just binary search problem. It's not that bad, and the others are just simple problems. Yeah. So thanks for watching, guys, and I'll see you in the next one.